Welcome back. 2013 Toyota Corolla, 1.8 liter, no AC. It's got a B1479 code. That's AC flow sensor code. Sensors on the side of the compressor. Unfortunately for this one, there are some of these Toyotas where you can get the sensor from Dorman, which I don't like, but you have to buy the whole AC compressor. You can't get the sensor separately. So I'm testing the sensor. With the AC off, car running AC off, it should be greater than 3.5 volts measured from the red wire, which I'm tied into on that sensor. With the AC, I'm sorry, it should be lower than that. I'm gonna get my numbers mixed up. I'll have to go back and look at it. But when on high, AC on high and the fan all the way up, I believe it's supposed to be over 3.5. So what I'm saying, I'm tied in, it's 2.3, no matter what I do. It's never changing, nothing. It's not doing anything. So the way to test this, if I figure out what I did, just put my magnet down. It's the sensor, I'll show you this, but it's on the side of, I'm going to restart this because once you start it, it changes. I had to restart it because I had done this test, and once you get it running, it runs. I was able to control the compressor with my scanner. Turn it on, comes on, no problem. 2.3 volts. It's not going to come on. It's got to be greater than 3.5 volts. I can put this magnet and reach down in here and put it on the sensor, and maybe you'll hear it. Just kicked on. The voltage is coming up. Not very great. 3.1, should be higher than that, but it changes. Take the magnet away, right back to 2.3. But now the compressor's engaged, and as long as the car's running, it will work. As soon as I cycle that key, it's not going to work again. This sensor's bad. The sensor's no good, so we're going to have to pull the compressor on this and replace it. So that's what we're going to do and fix this issue. I'm looking down at the AC compressor and follow the screwdriver. That's your AC flow sensor right there. So I'm tied in, I don't know if you can see that, to the white wire. That should be a 5 volt reference. The red wire is your signal, is your voltage coming out of the sensor. And I'm not getting any variation at all from that sensor unless I put a magnet on it. I can change it, but otherwise it's not working. So we're going to basically recover this system and pull this compressor out of here and end up replacing this compressor because I can't get the sensor by itself. Just wanted to show you here too, looking at this, I've got about, probably, it's settling back down, but I've probably got between 80 and 90, and it's probably 90 degrees today, PSI in this system statically. It was low when I first got it. It was like 10 PSI, which I don't know how, it came from somewhere else where they tested it, and I'm like, I don't know how they tested it like that because it didn't have enough refrigerant in it to even attempt to kick the compressor on. So I put some in it, just enough to bring it up so it had enough that it will kick the compressor on, and it did. I was able to get it to kick on. So, but it does, you need to check that first. You need to check to make sure that you have sufficient pressure in the system. Don't overfill it, but you need to have some in there. Make sure it's not empty so it will kick the compressor. If it's too low, the compressor won't come on at all. Okay, I've recovered this system using the recovery machine that I have. It's empty. We're going to go underneath now. We're going to disconnect the electrical connectors to it, unbolt the compressor, undo the lines, pull this compressor out, and work on swapping a new compressor in. All right, so there's a shield, a plastic shield I've taken off the front here to get at this. This is on towards the passenger side. We've just got 4 bolts, 2 at the top, 2 at the bottom, one bolt for each line, 2 electrical connectors, and then of course a Christmas tree which holds the electrical loom, wire loom to the side of the compressor. We're going to undo them, take this out of there. First we've got to go and undo this serpentine belt. I'm going to go release the tension on it, take that belt off. This belt needs to be replaced, it's all torn up, but let me do that. I'm not going to try to show that to you. It's pretty straightforward, a couple bolts, no big deal. And then when I get it out of there, we'll come back and I'll show you what's next. All right, You can see it's out. I did leave this top stud in. There's a stud here and a bottom stud down here somewhere. I don't know where exactly, right here. And you can slide it out with leaving this one in. I left that one in because this hole has a insert that'll hold it in place, and you can slide it on this. It holds it for you, makes it easier to put it back in. I have put new O-rings on both my lines. Your compressor usually will come with them. If not, you need to replace those O-rings, one there and one you can't see because I have it out of my way. But let me slide this back in place, bolt it back in, make my connections, my electrical connectors, and then we'll hook it up and draw a vacuum on the system and make sure we have no leaks. Alright, there it is. Kind of hard to show it, but everything's bolted back. My electrical connectors and my lines are back in. When you put these O-rings in, either you use a little bit of PAG oil to lubricate them. I use stuff, I think it's called Nylog. It's for HVAC, and it is a lubricant, just a little bit on there. Just you don't want to put them in there dry and take a chance of cutting them, you know, nicking them or rolling them. So just put a little lubrication on those O-rings when you put them in. Bolt everything back together, everything's ready to go. Let's go put the serpentine belt on and pull a vacuum on it and see how it does. Oh no. Got it unplugged. Just gonna let that run, pull it into a vacuum, which it's already done. Let it pull it down some more. We'll let that run probably 20 minutes at least. Then we'll shut it off and let it sit and see if it holds the vacuum. I've got my scale set up. I've got to put about 0.97 pounds in this, just under a pound. There's a range, that's kind of right in the middle. I'm going to go in, start the car, max AC, turn the fan all the way up, let it run, and then we're going to pull in on the low side and charge this. We're right there where we should be. Should not put any more in there. I can hear it kick on. It came right on. Fix this. And it's cold. I get my thermometer. I got a thermometer in it, but I get my infrared out and see what it's down to. But it's cold, so that's good. So that sensor was causing the problem, which is what we thought. You know. Never 100% sometimes, but you know, 99% that sensor wasn't behaving. And now we look good. Well, that fixed it. At idle here, sitting in the garage, about 40 degrees coming out of the vent. Good. 16-year-old car. 16-year-old, 2013, 11-year-old car, still good. So that AC flow sensor was what the issue was, and that's what it looked like, looking at, you know, the voltages coming out of there, and the fact that it It wouldn't move. You put a magnet on it, you get the compressor to kick in. Unfortunately, like I said in the beginning, you can't get the sensor for this. They don't sell it by itself, not for this particular car. You have to buy the compressor. So put the compressor in it. We'll just, unhook everything. Basically, we're done at this point. Put the plastic undershield back under that. I didn't show you taking off, but you have to take off to get at the stuff. And that's it. Not that difficult. Pretty easy compressor to get to. Pretty easy to get out and replace. Some cars not so easy, but this one pretty easy. If you need to do this for your Toyota Corolla, I hope it helps you out. If you like the videos, click the like and subscribe below. Thanks for watching.